Welcome back to the PID Control with Arduino lecture series. In this lecture, I'll finally be showing you how to approach tuning the PID gain constants for your system. Here is a famous table that shows the effect each gain parameter has on the system. The main advantage of each gain parameter are these. Now, one thing I want to mention is that you need to be very sparing with your derivative term, because although it may decrease the overshoots the higher you set it, if you set it too high, it can cause your system to be very sensitive to even the smallest errors. This can cause a very turbulent control signal that will cause your system's output to jitter. Now, although this table provides us with a good insight to how each gain affects the system response, it doesn't tell us what values we should start off with for our specific system. And this brings us to the famous Ziegler-Nichols closed-loop tuning method. The first step of this method is to put all the gains to 0, and then slowly increase the proportional gain until the output begins a steady oscillation upon startup or a disturbance. This proportional gain is known as the ultimate gain, Ku. And we also need to know the period of this oscillation, which we'll call Tu. Now, before we go any further, let's try this method on the propeller arm system and obtain the Ku and Tu values. I've set the derivative and integral gains to 0, and I'm starting up with Kp equal to 1. We can see that our system is not oscillating yet. Let's increase our Kp value to 2.5. We can see that it's overshooting, but the response does not oscillate consistently. Now I keep doing this iteration until I get to Kp equals 3.4. Now upon the startup and adding disturbance, we can see that it's oscillating consistently. We now have our ultimate gain value of 3.4. Now we need to know the period of this oscillation. From taking a look at the serial plotter, I estimated it to be around 1.2 seconds. Now that I've gotten the Ku and Tu values for my system, I'm going to simply plug them into the formula provided by the method. And now here are the P, I, and D gain constants I get. Let's try these out. As you can see here, it's regulating pretty well. Now I can always adjust these values from here on if I wanted to tweak the performance of my system. But at least using the following method, I was able to obtain a starting point for my controller. So this concludes the lecture series. I hope you all now know how a PID controller works and how to implement it on the Arduino. There's still a lot more theory behind PID control and its tuning that I did not cover in this course, but I hope the lecture series at least gives you a starting point into implementing it on your design, whether it's on the Arduino or another microcontroller. If you had trouble understanding a concept in this series, or maybe noticed an error in my code or in my explanation, please shoot me an email so that I may address it. If you like the series, please let me know in the reviews, and if for some reason you did not enjoy the course, let me know anyways. I'd appreciate some constructive feedback. With that being said, have fun, go build something, and hopefully I'll run into you in another lecture series. Take care.